Now let me introduce some basics about the container network mode. Basically, I take a more neutral solution, neutral standpoint about the container, the solutions of the style favoring and the companies or brands. Docker is using container network model and Podman is using container network interface, so they are actually different in the technologies. Yeah, I just want to share about 3 types of useful container network mode for debugging. It will help you a lot with troubleshooting. Great. Let me introduce these 3 modes. You can see that the first mode is called bridge mode. That's a so-called command line. You have mentioned that each and every network namespace on their own IP and space, so you can do a lot of different work on them. If you use the bridge mode, then you can have the scope within the bridge mode, as shown here. If you think your bridge is problematic, then we will use it in the bridge mode to do the troubleshooting. The next mode is to reuse the container. You can see that I add a net parameter and used another container namespace to do the operation. The debug container namespace and container a namespace are put together. They can share the same IP. If you suspect that there are some problem with the container A namespace, so this container mode will be very suitable for you to do troubleshooting. The third mode is to use the net host. Basically, it is based on the container that can control the whole environment of the network. If you suspect that the host is having some problem, then you can use this mode to do the troubleshooting. Yeah, the host of the node. So as long as you can, you are familiar with the namespace of each parameter the scope is for, then you can have a very good insight of what the modes are about. We have just talked about the container part, so you can jump to another level and think about how to do troubleshooting on the Kubernetes networking. Usually, Kubernetes projects do not have implementation and the network models implemented. Yeah. The implementation usually need the CNI computer network interface to implement. One of the most popular CNI is Flannel and another is Calico. So the scope of my presentation will be limited to these two CNI, which are more neutral. Next, I will show 5 types of Kubernetes network traffic troubleshooting and also 4 different levels of debugging methods. Let me first introduce the 5 different methods. Before talking about the Kubernetes, I should clarify some concepts. Each pod can contain 1 and 2 multiple containers. Each pod of containers will share the storage and network space. So in Kubernetes, the smallest implementation level is a pod, but not a container. Having in pod as the smallest unit in Kubernetes causes a great difference between troubleshooting in the container and in Kubernetes. Firstly, if within one pod we have container-to-container traffic, how to we do the debug? We have mentioned that in the same pod, different containers can share the same IP. Yeah, so in the right we show that we can use the container to of the same pod to do this work. So on the left, we show a command like how we can do when we have more than 1 containers in the pod. Pod A and Pod C have namespaces with different IP, so they actually do not share the IP namespace. The second mode is pod-to-pod traffic, but on the same node. On the same node, traffic will be put through in the same node. But it is very important to know whether your part being troubleshooted on the same node or different. So because the troubleshooting methods will be very different. The third traffic model is the when the port-to-port traffic is through different nodes, so it will go outside the nodes for our communication. So under this situation, and there traffic and the forwarding rules will follow the IP tables and the routing tables. The fourth model is part to surface, which is a very basic Kubernetes application. No, we just use the internal Kubernetes service for the internal load balancer. So we actually based on the part to service to do the communication. We basically use the IP table to do the round-robin scheduling. The final model is when your service traffic has to go out to the internet or get traffic from the internet. So this will go through two different routes. So in this model, we will separate the two troubleshooting methods in terms of direction, like ingress from the routing internet traffic into the Kubernetes, and egress, routing in traffic to outside, like to the internet. How do we actually implement the network troubleshooting? Oh, okay. Okay. No. Oh, can you? So actually, we can go into a shell and running containers to do a exec for the troubleshooting work. Overall, it is a very simple application that we use within this green part. A very simple application. The second level is debugging on the namespace level. One tip is that we use the Kubernetes control with the node selector and the host to do the control. And you can see that we specified the computer. We only use the node of compute one, so the two results are the same. In reality, the traffic goes like this. If within the namespace, you can test other parts within the same nodes or across different nodes for the same namespace troubleshooting. That method is in the same command we add the host network through a parameter. So we put the debug container on the default file to operate so the IP it gets. So you see either login table in the debug part and the container OS will be exactly the same. Even though the OS in the debug part and the container OS are different, as you see in this example, debug part uses CentOS and the container OS uses Red Hat Linux Core OS. So in this figure, you can see that the part, the debug part uses the whole same whole part to do the namespace control. So you have two ways, two choices when you do this running part level debugging. After the 1.18 version of Kubernetes control, there is support for the alpha debug functionality. Or you can also install the tool called Kubernetes Control Debug. So yeah. What the debug does is that it clones the one part to another exactly the same import. So any debugging we're working on the clones part will not affect what your original part does. So it is all about Kubernetes and container debugging methods. So here's the environment I have used, like Kubernetes version 1.17, if you're interested. Finally, some people may want to ask how to obtain or make a debug container. Here are 2 recommended ways. Firstly, it is very easy. You just need a base image. Adding the desirable never diagnostic tools into it. Well, there's another open source solution. We call it NetShoot, which has already included many network troubleshooting tools ready to be used. Here are some references of what I have shared. Welcome to getting more information from the references. Thank you, everyone, for listening. Welcome joining to our the community Cloud Native Taiwan user group. Thank you, everyone.